Hello Java programmers, welcome back to my video. This is part 4 of control structures in Java. Please make sure to watch my videos for part 3 and 2 and 1 of control structures in Java before watching this video. In my videos for parts 2 and 3 of control structures, I had explained the wide iteration statements as well as different ways to formulate algorithms that have loops. In this video, I will cover two other iteration statements, including the for loop and the do while loop. Let's start with the for repetition statement. The for statement is a natural counting loop. It specifies a counter-controlled repetition in a single line of code. Recall that this code with the while loop is a counter-controlled repetition, with variable count being used as the control variable. This counter-controlled repetition code is equivalent to this for loop, which combines the initialization code before the while loop and the code that updates the control variable into the same line of code that contains the loop continuation condition. The general syntax of the for statement consists of the header followed by the loop body. The body statement can be a single statement or a compound statement which is enclosed between a pair of braces. The for statement header starts with the for keyword followed by three components in a pair of parentheses. The first component in the header is the initialization, which typically initializes the loop's controlled variables and optionally declares the control variable. The initialization in this example both declares the control variable counter to be of type int and initializes it to value 1. The second component is the loop continuation condition, which determines whether the loop should continue executing. It typically involves comparing the control variable to a threshold value, such as counter less than or equal to 10. The third and also the last component in the for statement header is the update action, which typically modifies the control variable's values so that the loop continuation condition eventually becomes false. The simplest update action is to increase or decrease the control variable by 1. The two semicolons in the for headers are required. If the loop continuation condition is initially false, the program does not execute the for statement's body. Instead, execution proceeds with the statement following the for. Note that every for loop can be rewritten as a while loop. In particular, the general syntax of the for statement is equivalent to this while loop, with the initialization being placed right before the while statement, and the update is placed at the end of the body of the while statement. When the for statement begins executing, the initialization executes first. Next, the program checks the loop continuation condition, which is between the two required semicolons in the for statement header. If the condition is true, the body statement of the for loop executes. After executing the body of the for loop, the program performs the update action, which appears to the right of the second semicolon in the for header. Then the loop continuation uh, test is performed again to determine whether the program should continue with the next iteration of the loop. When the condition is false, the loop terminates and the next execution could be of the next statement after the for loop. Recall that you can use the while statement to implement any iteration structure in your algorithm. However, typically, the for statements are used for the counter-controlled repetition, and the while statements are used to implement senator-controlled repetition. Also, there's a small difference between the for statement and its equivalent while statement. That difference lies in the scopes of the control variables. In particular, if the initialization in the for header declares a variable, that variable can only be used within that for statement. In other words, the scope of that control variable is within the for statement only. In general, a variable scope defines where the variable can be used in a program. A bigger scope is a method. So when we say a local variable, we mean it can be used only in the method that declares that variable and only from the point of declaration through the end of the method. Here is an example that demonstrates the difference in the scope of the control variable in the for statement and in the equivalent while statement. The initialization in this for header declares variable counter to be of time int. So the scope of this variable counter is within the for loop only. This means that if you try to access the counter variable outside of this for loop, then you will encounter an out of scope syntax error. For example, here you try to print out the variable counter after the for loop. Okay? So then you will get a syntax error. In contrast, in this while loop that is equivalent to the for loop above, the initialization that declares a variable counter is placed before the while statement. So the scope of variable counter in this code is the entire method containing this code starting from this point of declaration. This means that you can access the variable counter after this while loop without any error. That's one difference you should pay attention to when converting a while loop into a for loop. Let's go back to the syntax of the for statement. In the general format of the for statement, there are three components in the for header. However, all those three components are optional, meaning you can omit any of them or even omit all of them at once. But if the condition part is omitted, the condition of the loop is always true. Therefore, it creates an infinite loop. You might omit the initialization part of the uh, of the for header if the program initializes the control variable before the loop. For example, instead of putting the initialization of variable counter in the for header of this for loop, you can place it before the for loop. Note that in this case, it will change the scope of the variable counter. So its scope is no longer within the for loop only. Also, even though the initialization part is omitted, the first semicolon to the right of the initialization part is still required. You might also omit the update part if the program calculates it in the loop body. For example, instead of placing counter plus plus in the header, as in the top one here, you can place it at the end of the loop body. And in this case, you still have to place the second required semicolon in the for header. Although it's legal to omit one or more components in the for headers, that style of programming is not encouraged because it reduces the readability of your program. The syntax of the for statement doesn't require a semicolon at the end of the for header. However, many novice programmers place a semicolon immediately to the right of the right parenthesis of a for header, and that often leads to a logic error because it makes the body of that loop an empty statement. For example, consider the for loop that prints out the word hi 3 times. But if we place a semicolon at the end of the for header of this for loop, the body statement, which prints out the word hi, becomes a statement after the for loop. So it executes only once instead of 3 times. So by placing this semicolon, the code fragment will print out only one hi instead of 3 hi's. The logic error resulted from the semicolon at the end of a for header can sometimes lead to a syntax error. For example, consider the for loop that has the control variable counter iterate from 1 to 10 and prints out the value of counter. So the intended loop body accesses variable counter, which is declared inside the for loop, and so should have scope within the for loop only. If we place a semicolon at the end of the for header, then the statement that prints out a counter becomes outside of the for loop. This leads to an out of scope error because it tries to access the variable counter outside of its scope. Okay, so in the for statement syntax, the initialization, the condition, and also the update component in the for header can contain arithmetic expression. It doesn't need to be just a simple comparisons and simple assignments like this one. For example, assume that a variable x has been assigned to value 2 and variable y has been assigned to value 10. Then the first for loop here is equivalent to this second for loop. So in other words, instead of writing j equal to 2, you can write j equal to x in the initialization. And in the condition, instead of writing j is less than or equal to 80, you can write j is less than or equal to 4 times x times y. And so here, instead of writing j plus equal 5 in the update action, you can write j plus equal y divided by x. In that case, the program will evaluate the arithmetic expression and then just perform the calculation as usual. Also, the update for a for statement may be negative. For example, you can decrease the control variable j by 5. Uh, and so in that case, you may start it with a higher value, and then the condition would be to test if it's still higher than a threshold. Okay? And then you continue to decrease it. So in this case, the loop will count downward instead of upward. Another detail in the for statement syntax um, allows you to have the initialization and update written in a comma separated list. For example, here we write the for loop with two assignments in the initialization. These two assignments expressions are separated by a comma. The first one initialized total to 0, and the second one initialized variable num to 2. And of course, both total and nums are also declared within this for loop. In the second example, the body of the for statement could be merged into the increment portion of the for header by using the comma. So the update portion of this for loop includes adding number to the variable total and then increase number by 2. Note that if you don't use the comma separated list in the update one, then you could put the total plus num in the body of this for loop, and that statement will be executed before the update action in the header. So therefore, we have to put it before the update action if you want to merge it into the header. Okay, so both of these are legal. Okay, it's allowed in the syntax of the for statement. However, as a good programming practice, you should limit the size of the control statement header, that is the for header, to a single line if possible. So in this code, it spans 2 lines of code that is very difficult to read. And also note that here you still need to put the semicolon um, because now the loop body becomes an empty statement. Now let's do some practice with the for statement syntax. In each of the code fragments here, we want to write a for loop that outputs the word hi 100 times. But some of them may have errors, and you need to find out those errors. So what is the error in the first one here? All right, so know that in the first one here, we declare the control variable n inside the for loop. And so we didn't declare any other variable n in the program. And so here we have the statement n equal 100, which is outside of this for loop. So what is the error that we can get here? It's an out of scope error. Okay? So in the second one, is there any syntax error? The answer is no. Okay, so you can, it has exactly 2 semicolons in the header. The update action can be empty, and because we move it here to the loop body at the end of the loop body. However, this one has a logic error because it starts n with 1 and it continues as long as n is less than 100. So when n is equal to 100, it will not print out the word high. So that means that it only print out the word high 99 times instead of 100 times. And this kind of logic errors is called off by one error. Here are 3 more code fragments that are supposed to output the word high 100 times, but they may have errors, either syntax error or logic error. Okay, so let's consider the first one. What error does it have here? So know that here the errors can be very tiny to notice, and so here we don't have the off by one error because we change uh, uh, n less than 100 to n less than 101. So it will loop from 1 to 100. Okay. However, so here note that we have a semicolon at the end of the for header. So that means that this statement is outside of the loop. Okay? So therefore, it will only print out the word high only once instead of 100 times. Okay? And so this error is a logic error caused by this semicolon. In the second for loop, let's see if it has any syntax error. No, right? It has initialization, it has condition, and it has the update action. But this update action is just multiply n by 1. So that means that it doesn't change the variable n at all. And n is initialized to be 1, and it um, satisfies the condition that n is less than 101. Right? And the update action doesn't change the value of n after its iteration. So therefore, as a result, it creates an infinite loop. So that is a logic error. How about the last one here? So in the last one here, the initialization is empty. Okay? And here the condition is n is less than 200 and n is initialized to be 0 before the loop. But in the update action, it increases n by 2 after its iteration. So in this case, it looks strange, but actually it works perfectly. There's no syntax error, no logic error, because here it's only, so it start n with 0, and it's only increase n by 2, and so it would print out high for the value of n equal to 0, and then 2, then 4, etc. So there are 100 value of n's uh, that is even and between 0 and less than 200. So, so this code fragments doesn't have any error. Now I'm going to show examples of complete Java programs that have a for statement. The first example is the class average program. Recall that this is the pseudocode algorithm that uses counter-controlled repetition to solve the class average problem. And we had discussed this problem in part 2 of control structures. We had also implemented this algorithm using the while statement, but now we will implement it using the for statement. This is the first part of the class average program that we had implemented using the while loop. Here we place the initialization of a grade counter variable before the while statement and place the increment of the grade counter variable at the end of the while statement's loop body. We now rewrite this program using the for statement. By placing the initialization of the grade counter variable into the initialization component of the for header and placing the increment of the grade counter into the update component of the for header. Everything else is the same as in the previous class average program. The second example of a complete Java program with the for statement is the compound interest application. This application is to solve the following problem. A person invests 1,000 in a saving account yielding 5% interest, assuming that all the interest is left on the deposit. The problem is to calculate and print the amount of money in the account at the end of each year for 10 years. So here you can use the following formula to determine the amount on deposit in the account at the end of each year. Okay? So the formula is that A equal P times 1 plus R overall raised to the power of n. So here A is the amount on deposit at the end of the end years. Okay, so n is the number of years and P is the original amount invested, which is also called the principal. And R is the annual interest rate, which has the actual real value. For example, the 5% would be equal to 0.05 value for the variable R or parameter R. Of course, you can use Excel to calculate this formula, but here we will write a Java program to calculate and print the amount on deposit. This is our Java program named interest.java that computes the compound interest with a for loop. Before the for loop, it declares variable amount, principal, and rate, which represent the parameters A, P, and R in this given formula for calculating compound interest. It also initializes principal and rate according to the given compound interest problem. Then it displays the headers for the output, which consists of the labels for two columns, year and amount on deposit. After displaying the output header, the program proceeds with the for loop, which calculates the amount on deposit for each of the 10 years. This for loop is a counter-controlled iteration with variable year being used as the control variable. Variable year represents the parameter n in the given formula. The for header declares and initializes a variable year to value 1, uses year less than or equal to 10 as the loop continuation condition, and increases year by 1 as the update action. The body statement of the loop is a compound statement that consists of two single statements. The first one implements the given formula, and the second one prints out the year and the amount after calculating the amount for the year. This is the output we get after running the interest.java program. The output has two columns. The first one displays year, and the second one displays the amount on deposit for the year. There are 10 rows corresponding to the first 10 years. These 10 rows were printed out by the for statement. In order to display the output nicely in the column format as in our interest.java program, we need to use a format specifier with more options. In particular, to display the header amount on deposit, the interest.java program uses the format specifier %20s. The letter S in this specifier indicates the string type, and the number 20 indicates the output field width of 20, which is the number of characters reserved to display the output. That is, the printf method displays the value with at least 20 character positions. If the value to be output has less than 20 characters, it is right justified in the field by default. Here, the string amount of deposit has 17 characters, so there are 3 characters between the string year and the string amount on deposit in the header of this output. To output values left justified, you just need to precede the field with the minus sign, which is a formatting a flag. For example, you can write percent minus 20s as the format specifier. So then in this case, it will display the value left justified. So it begins from the left margin for that field. If the value to be output has more characters than the field width, then the field width could be extended to the right to accommodate the anti-value. In the second printf statement in the interest.java program, which prints out the value of year and amount in each iteration of the for loop, it uses the format specifier %4d to format the value of year. The letter D in this format specifier indicates the decimal integer type, and the number 4 indicates that the field width of the output is 4 characters. This is to match the space needed to print the header year, which consists of 4 characters. This printf statement uses the format specifier percent comma 20 dot 2f for the output value of amount. The letter F in this specifier indicates that the output is formatted as a decimal floating point number. The number 20 indicates that the value should be output right justified in a field width of 20 characters. This is to match the field width of the column header uh, amount on deposit. The dot 2 specifies the formatted number's precision. In this case, the number is rounded to the nearest hundredth and output with 2 digits to the right of the decimal point. The comma in the format specifier is a formatting flag, which indicates that the floating point value should be output with a group separator. Note that separator is specific to the user's country or location. In the United States, we use commas to separate every every 3 digits in the integral part of the number, and we use a dot or decimal point to separate the fractional part of the number. In some other countries, such as Vietnam and European countries, the use of commas and the dot are exchanged. So the comma is used to separate the fractional part of the number, and the dots are used to separate every 3 digits in the integral part of the number. In Arabic countries, they also use the comma in place of our decimal point, but they use single quotes to separate 3 digit groups in the number. The interest.java program we have seen uses this expression math.pow to calculate 1 plus r raised to the power of n. This expression is a call to method pow of the math class. However, this method call is different from other method calls we have used before. Recall that classes provide methods that perform common tasks on objects. Most of those methods must be called on a specific object of the class. For example, to call the method nextInt of the scanner class, you need to create a scanner object such as input, and then call the method nextInt on the input object by writing the object's name, then the dot, then the method name, followed by the arguments in parentheses. However, many classes also provide methods that perform common tasks and do not require objects to call. Those methods are known as static methods. The method pow of the math class is a static method which can be used for raising a value to a power. To call a static method of a class, you just put the class name in place of the object named as in this syntax. For example, to call the static method power of the math class, you can write math.power followed by two arguments in parentheses. The first argument is the base and the second one is the exponent. So math.power of x comma y calculates and returns the value of x raised to the y to the power of y. Both arguments of the method as well as its returned value are of type double. As a performance tip with loops, you should not include in a loop any calculations for which the result never changes. Such a calculation should typically be placed before the loop. For example, the assignment of a principal to 100 in the interest program should not be placed inside the for loop like this, because you only need to set a principal only once and use the same value of principal for every loop iteration. So no need to reset it to the same value in every iteration of the for loop. In the last example of for loops, I'm going to show nested for loops that display this multiplication table. This example is the multiplication table program. It first displays the top heading of the table. So there must be some space here. So that space are printed here. Then it uses a single for loop to display the number title below the table heading. Okay, so below that sequence of number in the title, there are some spaces here, so it needs to print those spaces before the for loop. And inside the for loops, it use it uses the variable j as the control variable, and the variable j goes from value 1 to the value 9 for during the looped iterations. And each iteration, it prints out some space followed by the value of j. So then it makes the title like this. And then and then it displays the line separating the number title and the table body. The table body has 9 rows, so the program uses a for loop that iterates through the rows with the control variable I. So when I is equal to 1, it prints out the rows for starting with the number 1, okay, in the header. And when I is 2, so it print out the rows starting with 2 in the row header. In each iteration of this for loop, it prints out the row heading, which is the value of the variable I, followed by a space, then a vertical bar, and then another space. Then it has an inner loop, for loop that iterates through the columns of the table with the control variable j, and displays the product of I and j. After the inner for loop, it prints out a new line to move to the next row in the next iteration of the outer loop. Now let's move on to the last repetition statement in Java, which is the do while statement. The syntax of a do-while statement starts with the keyword do, followed by the body statement and then the while part. The body statement can be a single statement or a compound statement. This syntax shows a compound statement as the body statement of the loop. The while part starts with the keyword while, followed by the loop continuation condition in the parentheses as in the header of a while statement. But in the do while statement, you need to place a semicolon at the end of the while part. The control flow in the do while repetition statement is a little bit different from uh, that of the while statement and the for statement. In the while statement, the program tests the loop continuation condition at the beginning of the loop before executing the loop body. And if the condition is false initially, the body of the while statement never executes. In contrast, the do-while statement tests the loop continuation condition after executing the loop's body. Therefore, the body always executes at least once. The flowchart of the do-while statement makes it clear that the loop continuation condition is not evaluated until after the loop performs the body statement at least once. When a do-while statement terminates, execution continues with the next statement in the sequence. This program shows an example of a do-while statement in Java. So this is very simple program. It just has a variable counter, okay? And then it has a do-while loops that prints out the value of variable counter and then increase the value of the variable counter while the counter is less than or equal to 10. So it basically just prints out 10 numbers from 1 to 10 using the do while loop. Of course, in this case, you can rewrite these do while loops as the while loop is still produces the same result. Recall that braces are not required in the do-while repetition statement if there's only one single statement in the loop body. However, many programmers include the braces to avoid confusion between the while statement and the do-while statement. Thus, the do-while statement with one body statement is usually written like this one. So it still has the uh, braces, even though there's just one statement inside the braces. Here is an example that shows the difference between the while statement and the do while statement. Let's now consider these two loops. The first one is the while loop, right? And the second one is a do while loop. In the while loop, uh, we uh, we have the condition count less than 3. Okay, in the do while loop, the loop condition is also count less than 3. And before the loop, the variable count has been declared and initialized to the value of 3. Okay? So that means that the condition count less than 3 is false when it is tested for the first time. And so in the while loop, the condition is false initially. So therefore, the loop body doesn't execute. But in the do while loop, the loop body is executed before the condition is tested for the first time. So therefore, it still print out the word hi in the do while loop, but it doesn't print out the word hi in the while loop. So these two loops are not equivalent to each other. That is because of the initial value of the variable count. So in other words, in a do while loop, the loop body always executes at least once. Remember that. And in a while loop, the loop body may never execute. So that's the end of this video. Thank you for watching, and I hope to see you again in the next video, which is part 5 and also the last part of control structures in Java. Happy programming!